Hantzsch synthesis of pyrrole. Synthesis of pyrrole comprises of two major steps. Before going with synthesis, let us study some important points like if N is bonded with three different atoms, then it contains lone pair, and if N is bonded with two different atoms, it contains negative charge, and if N is bonded with four different atoms, it contains positive charge. For synthesis, we require two compounds, one beta ketoester and second alpha haloketone. First, beta ketoester. This is the structure of beta ketoester. This is the ester group, which can be written as C double bond O, O, C2H5. ET is ethyl group. Ester group. This is alpha carbon and this is beta carbon. To beta carbon, oxygen keto group is attached. Now, for synthesis, attack of nucleophile takes place. Here, nucleophile, that is ammonia, with its lone pair attacks on the beta carbon, which results in the bond break and comes over oxygen. In the next step, now N is bonded with four atoms, therefore it contains positive charge, and due to the bond break, oxygen contains negative charge. In the next step, deprotonation and protonation takes place. One hydrogen is removed from here and it is added to the oxygen, which is seen in the next step. Here one hydrogen is removed, therefore it becomes NH2, and it is bonded with three different atoms, therefore it contains lone pair, and here H is attached, therefore OH becomes. Now, one hydrogen is removed from the alpha carbon and bond is formed between these two carbons, and a carbon cannot have more than four bonds. Therefore, OH is removed, which results in the removal of H2O. Now, a new bond is formed between these two carbon, and rest all attachments are as it is. Now, in the second step, the product of first step is taken and a new compound alpha haloketone is taken. Now, this is the structure of alpha haloketone. This is a halogen. Here, halogen group is attached. That is, chlorine is attached, and therefore name is alpha haloketone. Now, your formation of a new bond takes place between these two compounds by removal of HCl. Now, here H is removed from this compound and bond is formed between this carbon and nitrogen. Here carbon cannot have more than four bonds, therefore this double bond breaks and forms bond with the alpha carbon of alpha haloketone, which results in the removal of Cl. Therefore H from this compound and Cl from this. HCl is removed and a new bond is formed between this carbon and this carbon, which is seen in the next step. Here the new bond is formed between these two carbons and double bond is formed between this carbon and nitrogen due to the removal of one hydrogen. Now here deprotonation takes place. One hydrogen is removed from this carbon and the bond is shifted between these two carbon, which results in the breaking of this bond and forming a new bond with this carbon, which results in the breaking of this bond and comes over oxygen, which is seen in the next step. The hydrogen is removed from this carbon and double bond is formed between this two carbon, and this double bond forms a new bond with this nitrogen and carbon, and over oxygen a negative charge appears. Now protonation takes place. One hydrogen is added to this oxygen. Rest all structure is same. Now one hydrogen is removed from this carbon and bond is shifted between these two carbons, and again carbon cannot contain more than four bonds, therefore OH is removed, which results in the removal of H and OH, that is H2O. H2O is now removed. Now we get the structure of pyrrole. This is the structure of substituted pyrrole. Just to remember the synthesis, I have highlighted 8 points which can be written as like first point, attack of ammonia, second deprotonation, protonation, third removal of water, fourth alpha haloketone joinings, 5 removal of HCl, 6 deprotonation and bond shifting, 7 protonation and 8 removal of water.